In this video, we'll cover section 2.3, rate of change and slope. Two things that we're going to talk about in today's video. We're going to calculate rate of change and we are going to calculate slope. Now, hint, hint, these are the same. They're going to be used in different ways, but they're going to be calculated the same way. So rate of change you can see at the top, a ratio that compares how one quantity changes on average relative to another quantity. One thing that you really need to remember is that with a rate of change, you're always going to simplify. So when I say ratio, what I mean is you're going to be writing a fraction. So you're going to write a fraction. It's very important that we remember to simplify that fraction. So you've actually heard rate of changes already before. You might have heard miles per hour, so how fast someone was going, or feet per second. These are rate of changes. Miles per hour or feet per second, that's the ratio of how much you're changing in distance compared to time. So we're going to look at example number 1. Jack went hiking this afternoon. He left from an elevation of 2,300 feet at 8 a.m. and hiked to an elevation of 5,400 feet at 4 p.m. What was Jack's rate of change in altitude? Okay, so first thing we got to look at is our units. We have feet and we have time. So we need to ask ourselves, is feet per hour, does that make more sense? Or are we going to say hour per foot? Well, hour per foot, hopefully you can already tell that that doesn't make sense. So in our ratio, we're going to put the change in feet to the change in hours. We are going from 5,400 feet to 2,300 feet. To find the change, we're going to subtract. And then in the denominator, we need to think about the change in hours. Now, we need to be careful here. What some people want to do is 8 a.m. subtract 4 p.m. What this is saying is he hiked for 4 hours. Now, does that make sense though? Let's think about this logically. If he started at 8 a.m. and went until 4 p.m., 8 a.m. to 4 p.m. is 8 hours. So when you're talking about time, you have to really think. 8 is what needs to be in the denominator. So if I simplify this in the numerator, I get 3,100 feet. In the denominator, I get 8 hours, right? Feet per hour. We need to simplify this though. So again, simplify it like we wrote above. Always simplify. I can divide both in this case by 4. You would be allowed to use a calculator for that. I don't expect you to do it in your head. So you get 275 feet per hour, for 2 hours actually. So that's the rate of change. What this means is every 2 hours, Jack hikes 275 feet. So every 2 hours, he hikes 275 feet. Okay, we're going to do a few more examples. If I look at example number 2, in the year 2000, 23,142 students applied to Southern Illinois University and 34,000 applied to Northern. In 2008, 29,000 students applied to Southern and 36,000 applied to Northern. Determine the average rate of change for both schools from 2000 to 2008. We're not going to do both schools. We're going to do Southern Illinois only. Okay, so for Southern Illinois, we have a year, we have applicants, we have another year, and another amount of applicants. So first thing we got to figure out is our units. We have number of students, and we have change in year, or year per students. Now, students per year makes more sense. You can hear just by hearing it that it makes more sense. Okay, so the number of students, the change in students, in 2008, 29,563 applied. In 2000, 23,142 applied. And then we went from 2008 to 2000, or really 2000 to 2008, which is 8 years. The numerator, we get 6,421, and in the denominator, we get 8. So what that means is, over 8 years, there were 6,421 more applicants. So over 8 years, there were 6,421 more applicants. Okay, and then example 3, real quick. We have pounds and we have dollars. So, pounds per dollar or dollars per pound? What makes more sense? Well, if you ever think about going to the deli, the price is given to you in dollars per pound. So dollars per pound. Now, in this example, we're given a whole bunch of information. We don't need all of it. Pick 2 pieces that you want to use. If I look at the change in cost, so I go from $32 to $16, and then I go from 44 pounds to 22 pounds. In the numerator, I get 16, in the denominator, I get 22. If I divide both by 2, I get 8, and I get 11. So $8 for 11 pounds. So for 11 pounds, it's going to cost us $8. Okay, so that is the gist, or the main idea, with rate of change. Always decide what units make more sense, and that'll tell you what goes in the numerator and what goes in the denominator. So if we flip to the next page, we're going to start talking about slope. Okay, so now we're going to talk about slope. This is really the slope of a line. Slope is the ratio or rate of change in y values compared to the rate of change in x values. Okay, so you guys have seen this formula before. First of all, M stands for slope. We're going to do rate of change in y. So on the other page, rate of change, that was subtraction. So we're going to subtract our y's. Rate of change in x, we're going to subtract our x's. So that is our slope formula. Notice, in both the numerator and the denominator, I started with x2 and y2. It's important you start with the same point. Now, we need to be able to identify positive slope, negative slope, undefined slope, zero slope. So I'm going to show us how to do that. Positive slope, you should remember, is rising. Negative slope is falling. Those two I don't think are too bad. Where we tend to have mistakes is undefined and zero. So I like to think of this like a face. Our nose is undefined slope, and our mouth is zero slope. So an undefined slope is going to be a vertical line. Our zero slope is going to be a horizontal line. Okay, so we just have a few more examples. Example 4, find the slope of the line that passes through 1, -3, and 3, 5. So I'm going to start with the formula that we wrote above. This first point is x1 and y1. The second one is x2 and y2. So using our points, we get 5 minus -3, so be careful there, and x2 minus x1. In the numerator, we get 8. In the denominator, we get 2. So we get a positive 4. Example 5, we have 2 different options. You can see in the line that we have these 2 points here. So that point to the left is -1, 4. The point to the right is 1, -1. So this is -1, 4. This is 1, -1. Remember, you're going over 1, down -1, so your point is always xy. So what we could do is we could plug these two into the slope formula, or if we're really tricky, hopefully we remember that slope is rise over run, so change in y over change in x. Well, if I start at my first point, I'm rising 1, 2, 3, 4, 5, and I'm running 1, 2. Because our line is falling, this is a negative slope. If you want to use the slope formula, that'll work. No problem with that at all. Another way, though, is rise over run. Okay, we're almost done. We got one more example. We're going to do example 6 together, and then we're going to skip example 7. Example 6. Find the value of r so that the line passes through the pair of points has the given slope. Okay, so our slope is equal to y2 minus y1. So this is x2, y2. I'm not going to have enough room. So y2 minus y1 over x2 minus x1. Now, fractions set equal to each other. Hopefully you remember, we can cross multiply. So we have 1 times 5 minus 8 is equal to 2 times r minus 1. On the left side, 5 minus 8 is -3. And then we get 2r minus 2. We add 2. We get -1 equals 2r. So r is -1/2. Okay, students always forget how to do that type of problem. It's not too bad. Just think about it. Set up your slope and solve for r. If you have any interest in doing that example number 7, you are welcome to. You're going to end up with r equals 9. If you have any questions, please write them down so you know to bring them to class.